big data to the masses. Roland is a zoologist with a broad interest in ecology and conservation, especially of mammals. He seeks out questions that are scientifically interesting, but also have real-world relevance through education or conservation value. He's an expert in using new technologies to study free-ranging animals, especially to track their movement with telemetry, GPS, and remote camera traps. He combines high-tech work with traditional methods, collecting data through new fieldwork and studies of museum collections. Welcome, Roland, and the floor is yours.
Great. Well, thanks so much for the invitation. It's a pleasure to be here. Today, I'm going to be talking about bringing big data to the masses, and I want to kind of start just to acknowledge that I'm really representing big research teams. Just sort of a small part of that. I'm going to be talking about the MoveBank project, which is for animal tracking, and especially in collaboration with Mark Michalski from the Max Planck Institute, and then Wildlife Insights, which is a big collaboration of multiple NGOs with lots of people involved, and I'm just kind of a representative of these teams today. So the motivation is really that the world is changing fast, and we've got warming planet, we've got more people every time, every year we've got deforestation, and we can see a lot of these things from remote sensing. But the wildlife side is much more difficult. And the point is that we need new data every year, right? The data you collected 5 years ago, by now, the world's different. And we also need timely analyses. We can't always be waiting 5 years for the PhD student to analyze the data. We need to know what's going on right now. And we need this for a variety of species and locations and scales. Fortunately, there's a lot of, we've never had more data, right? Here's an example of tracking data, the kind of information you can get from animals wearing GPS tags. These are real storks from Europe. And you can see here, they're migrating south, doing this perilous journey over the Sahara and getting into East Africa. And along the way, there's all sorts of other animals moving around. And sometimes we have tracking data for them, right? So here's some wildebeest from East Africa moving around, doing their own thing at their scale. And the amazing thing about these storks is some of them keep going all the way to South Africa. And of course, they're going to be running into other animals down there, things like African buffalo or elephants. And so the point is that we can have this, these are all real tracks that you're seeing here. We can collect some really interesting information about what these animals are doing at really high resolution, at really global scales. And in some ways, as these storks migrate back up during the spring, it also really shows how animals can really connect to the planet. And we get the same thing from camera traps, only from a different perspective, right? From one place. Everyone who's run cameras has probably made a similar time lapse to this, where you see the different animals walking through the forest, the different humans. In this case, this is a trail in Shenandoah Park, Virginia, and that we get these great data sets, these time series of animal activity. But of course, we also get all these pictures. Right? Each of these sequences has multiple pictures. This camera probably had thousands of images. And if you're doing a study, you probably have dozens or hundreds or possibly even thousands of points that you're running cameras, depending where you're running your cameras, the scale of questions and the scale that you're able to collaborate. You could potentially have many, many tens of thousands of points representing millions and millions of pictures. And how do you handle those pictures, right? How do you handle going through so many millions and millions of pictures? This is really some of the challenges, right? So the point is that with big data, there's a lot of promise because there's more details, there's a possibility to make more discoveries, and in many cases, we're getting the data quicker. But on the other hand, there's also a lot of peril in that it's hard to manage and hard to analyze some of these big data sets. And the motivation is that we have a lot of conservation challenges out there, right? This graph is showing the 3 billion birds lost example from 2019. And you all probably have your own local challenge or regional challenge that you're working on as working with conservation managers. And we have these solutions, but our motivation really is how can we make benefits of these wildlife data easier to access for conservation managers, right, who have a lot of different things to deal with. They're not necessarily able, have a lot of experience with working with big data. They've got lots of other things they need to do for their job. And then students that are just getting started, and a lot of times also motivation is developing world scientists who might not have access to the same resources. So this is the motivation. I'm going to be talking about how we do this in MoveBank for animal tracking, and in Wildlife Insights for camera trapping. Both of these are data types that are growing very fast. In MoveBank now we have over 3 billion locations. This camera trapping is showing the accumulation of camera trap data in eMammal, which is now being merged into Wildlife Insights, and is certainly many, many millions of locations. I'm not sure exactly how many at the moment. And so talking a little bit more specifically about animal tracking, really, you know, with the technology and the GPS and all the other types of ways we're able to collect data, we are in the golden age of animal tracking. There's so much resolution you can get. And MoveBank is designed to help manage and share those data. And so this is the front page of MoveBank. You can do searches to see what data is available. The green dots are studies that I have access to, and the gray dots are studies that I don't have access to. So you're not required to share your data at all. But I can click on a study, or I can do a search over there on the side, and I can find that there's research, and I can ask for permission to access those data. MoveBank now is over 3 billion animal locations and is growing by 2.5 million data points every day through live data. And that's just the location, the sensor data there. A lot of that's accelerometry or temperature or other sensor data is even higher. And we're now over 1,000 species that have been studied and archived in MoveBank. And the key thing is that data owners control access, right? So you don't have to share data, but if you want to, we make it easier. There's a recent paper in Science where Marley Tucker collected a bunch of data from different researchers and studied the effects of humans on animal movement. And so this is really what we want to do. Here's an example of how it's used by Wyoming Fish and Game as an agency archive. And so anyone that they permit or fund to do animal tracking research in the state is required to use MoveBank and share the data with, you know, the Wyoming Fish and Game login at MoveBank. You can see all those gray dots. I don't have access to those studies, but the Fish and Game Agency does, and I could ask them for access, and they could then approve it in MoveBank. So the sort of the details of the sort of, we call it the MoveBank ecosystem of apps is that we have animal location data streaming in through a variety of different live data feeds from the space station, from satellites, from GSM networks. You can upload your metadata. We have an animal tracker app, animal tagger app, to say, oh, this tag went on this animal. And then the sharing settings in MoveBank is how you control how people have access to the data. They can manually download it. We can publish it with the DOI so that it's a citable resource, and then anyone can use it without calling you or emailing you, but just by citing you. And then we have an API which serves it up to programs like R, so you can access it through the Move apps. And Animal Tracker app, where you can see on a map on your phone where the animals are in real time. We also have the ENVA data system that allows you to annotate environmental data like temperature and land use. And we have this new system called MoveApps, which I'm really excited about. It's not quite available to the public. It's still in beta testing, but it's really exciting because this is trying to overcome, the challenge that I face. And lots of you are really great at dealing with this code. But I find myself feeling like this Pokemon of like, I don't know what I'm doing. And there's so many different R packages that it's really hard to keep up with. So the way MoveApps works is we have these apps, which are small little bits of code. The code's behind the scene. You don't see the code. You just see this little window where you can change the settings and say, okay, segment data by speed. That will show animals that are moving very fast differently. And what we can do then is string these apps together into a workflow. So this workflow is a migration mapper that's got apps for removing outliers, thinning the data, segmenting the data, and then making a raster out of that. And here's what that does with some golden eagle data from Carol McIntyre in Alaska. And we can map that out then at the raster and see, oh, look, there's actually a really big concentration of that. And if you say, oh, well, maybe I want a higher resolution, you can just change a little setting in the app. You can rerun the workflow and get that in higher resolution. So that's the Move apps, and I'm going to move on now to talk about animal tracking data and wildlife insights. Tracking data is also growing very quickly. As you probably know, more cameras, more studies. We're learning a lot. Initially, Bill McShay and I at the Smithsonian developed eMammal to handle these data, and now we're working with Wildlife Insights, which is doing beta testing now, but will be released in May. And basically, the idea of Wildlife Insights, which is a big collaboration between a bunch of different NGOs and Google, is to have artificial intelligence to help identify the species, and then have automated analytics to extract, the insight to get the analyses basically in a more automated, easier way. And so the workflow is basically that we use artificial intelligence to classify the pictures, but then a person still goes through and verifies it. AI is not good enough to do this without some kind of quality control. But the great thing is then those processed pictures become training for a refined and better AI. So the AI is going to continually get better as we get larger libraries of training data, and we start adding more bells and whistles to the AI. And then we have the metadata, and from that we can do select, filters, and analyze a variety of things. So the parts here on the right, the blue parts, are still in development. We have a great plan for it. We have a lot of this funded, so we'll be developing it over the next year. The parts on the left, they're done and working, and we're sort of testing, and we'll be releasing that, I think, in May. And what I want to emphasize about how this helps this cyber infrastructure of Wildlife Insights and eMammal before it enables a massive collaboration. So if you want to do a study and you had a couple buddies and you're like, hey, let's all pull our camera trap data together and do a study, they could send you the data and you could drill through it and you could combine it and do your analysis. It's a pain, right? Because somebody uses a different taxonomy and somebody else classifies their data a little differently. But you could do that with 4 data sets. But when you start talking about dozens or hundreds or thousands, it becomes impossible. And you really need this cyber infrastructure to manage that. So I want to show you an example of our statewide citizen science camera trap survey, where we work with thousands of volunteers to sample over 4,000 locations across the state, getting locations in every county. And just as a perspective, I looked on Google Scholar for the last 10 camera trap papers published in peer review, and they averaged 99 sites, 25 to 221. We have 4,000, right? So it's an amazing data set. We're doing lots of projects with it. I don't have time to talk about all the different biology and wildlife management projects that we're using this data for. But maybe next time I can go into those. But that wasn't enough. Bill at the Smithsonian said, well, why not scale this up? Let's go bigger than a state. Let's go for the whole country. And so we launched a project along with Mike Cove called Snapshot USA, with the goal to try to get cameras in every state and every habitat type. And we said, okay, let's just do September and October, a relatively brief window of time. And instead of citizen scientists, let's work with scientists, right? You guys know how to set cameras. You have your own cameras already. And so we standardized the protocol. Everyone used, in this case, eMammal to share the data. And it worked amazingly well. In 2019, we had 127 participants across all 50 states. And we got 1,500 locations surveyed across 109 arrays. So really, this is, I think, in some ways, the first ever nationwide mammal survey. So 80 different species of mammals, really exciting. 2020 is complete. We've done it again. This is right. So I should mention that the 2019 paper is in press, and everyone who ran cameras is a co-author. And the 2020 data, we're cleaning it up now. All the data is in, and we're going to publish those as well. Everyone will be a co-author. We're also looking at 2021, hopefully. So we'd love some more data in South Dakota or wherever you're from. If you want to sign up for next year, we'd love to add you. And we're also looking to expand possibly this as kind of a sustainable model for doing monitoring over large areas on a regular basis, and expanding possibly into Europe next year as well. So one of the fun things we're getting ready as we publish our paper, we've said, well, which sites had the most mammals? Let's compare all these 109 sites and see who had the most deer or the most rabbits or whatever. So South Dakota finished in the top 10. So think about, what mammals do you think South Dakota finished in the top 10 for? There were actually 2 different species, 2 different groups. One was raccoons. You guys were number 10 for the one South Dakota site, number 10 in raccoons, and number 3 in rabbits and hares. So combining all species together. So congratulations on your bronze medal in rabbits. So in conclusion, I hope you see that, how we're working to bring, wildlife big data to the masses, meaning that it's a lot easier to work with, to access. and to learn from, and that there are a lot of potential and pitfalls. Within MoveBank, we supply animal tracking data management. We have this new innovative, I think, MoveApps platform. I don't know of anything else in it like it in ecology, or maybe even in science. Maybe there is. I'd love to know about it so we can learn from them if you know of one. And the goal is to get really, easier insights from tracking data for conservation and management. And then Wildlife Insights, which is still in the beta form, but is really moving along well. Is camera trap data management, has AI to help improve the efficiency of getting data in, and automated analytics for getting sort of insights out. And this really enables large scale collaboration. So that's the end. I'll end with Deer from Snapshot USA, South Dakota. And looks like I maybe have some time for questions. Thank you.
You do. Go ahead and ask questions of Roland if you have any. I feel like you probably could have talked for an hour or two. Roland.
I hopefully I wasn't talking too fast there. I usually cover this in a longer period of time. This is my first time trying it in 15 minutes. So I threw out a bunch of slides that it was heartbreaking to throw out some of the slides, but hopefully I didn't talk too fast.
You did a great job. Thank you.
I see Amanda has a question or a hand up.
Hey, Roland, great talk. Thank you so much. You said that the 2019 data is in press. Is that already out? Or do you have a link to it?
I don't, but I can send it to you if you want it. It's in press in ecology. So it's accepted.
Okay, awesome.
They haven't given us a publication date yet, so I'm not sure exactly when it's coming out, but
Okay.
that's the general idea, is that, we'll make the data public and then people can just use it for whatever, and just cite the paper.
Sweet, thanks.
Looks like I could have kept a couple extra slides in there.
Anyone else?
Hey, Roland, Rob Lonsinger. Thank you for doing this for us. Appreciate it.
Pleasure.
Can you hear me okay?
Yeah.
I wanted to quickly ask you, when I see things like MoveBank, I get a little intimidated by sort of what it might take to start using something like that. It seems like it would have a pretty steep learning curve. Can you comment on that? Like, are there resources, I guess, for folks like me who want to use it, but feel a little intimidated by the workflow?
Yeah, well, so MoveBank, it's about, from the basic level, it's about getting data in and then managing, working with the data once you're in there. And, we definitely, I'm a biologist and this is software development. And that's something that we struggled with for a long time. MoveBank's been around now for 13 years. And so we've gotten it to be a lot more user-friendly than it used to be. No doubt at the beginning, there were all these little tricks and it's like, it was really hard, but we've slowly over the time, I think made it easier and easier to use. We have, I think also over that time, really improved our user manual, instructions, so you can read through there. And we also have staff who can help you get started. So Candace works in my lab and her job is user support. And so if you want to send her a bunch of data, she can create a MoveBank project for you and, make you the PI, and then you're off and running. Or if you want her to help, if you're trying to figure something out and you're having trouble with something, you can just email her, and that's her job, is to help people to get that set up. If you've got a new live feed of data coming in from some, GSM tags or Argos tags, she can help you get that set up. So I would say a combination of the user manual and our, Candace's user support. Hopefully we can get you going. And the point, the other point is, as you start getting bigger and bigger data sets, it's, you got to have some tool to manage it. It's not, at some point, Excel isn't going to work as well for you. And so I think it'll be worth a little bit of investment.
All right. Well, thank you, Roland. Appreciate it. This is really interesting.